Quantum superposition. Quantum superposition is one of the core principles of quantum mechanics, the branch of physics that deals with the behavior of particles at the smallest scales, such as atoms and subatomic particles. At its heart, quantum superposition refers to the idea that particles like electrons or photons can exist in multiple states or positions at the same time rather than being in one fixed state or location. This idea challenges our everyday understanding of how things in the world work, where objects seem to exist in one specific place or state at any given time. To understand quantum superposition, it's important to start with how quantum particles behave differently from the objects we experience in our daily lives. In the classical world, things are either in one place or another, and they have a definite speed or position. For example, a ball can either be on the floor or in the air, but it cannot be in both places at once. However, at the quantum level, particles do not follow these same rules. Instead, they exist in a kind of cloud of possibilities, where they can be in several places or states at the same time. Imagine a particle like an electron. In the classical sense, you might think of it as a tiny ball with a specific position and speed. But in the quantum world, before we observe or measure the electron, it doesn't have a single, definite position. Instead, it exists in a superposition of multiple positions at once. It's not that the electron is physically in all these places at the same time, but rather that it exists in a combination of all possible states. Only when we measure or observe the electron does it collapse into one specific state or position. A famous thought experiment that illustrates this strange concept is Schrödinger's cat. In this thought experiment, a cat is placed in a box with a quantum particle that has a 50% chance of decaying, which would release poison and kill the cat, and a 50% chance of not decaying, leaving the cat alive. Until we open the box and observe the cat, according to quantum superposition, the cat is both alive and dead at the same time. Only when we open the box and observe the situation does the cat become either alive or dead. This thought experiment helps demonstrate how quantum particles exist in multiple states simultaneously, and how observation plays a key role in determining the outcome. Quantum superposition is not just a theoretical idea, it has been confirmed through many experiments. One of the most famous experiments that demonstrates superposition is the double-slit experiment. In this experiment, a beam of particles, like electrons or photons, is directed at a barrier with two slits. If we send particles through the slits one at a time and don't observe them, they behave like waves, creating an interference pattern on a screen behind the slits, as if the particles passed through both slits at the same time. However, if we observe which slit the particles go through, they behave like particles, and the interference pattern disappears, as if the particles chose one slit or the other. This experiment shows that particles can exist in a superposition of both slits at once, but the act of observing them forces them to choose a specific path. The idea of quantum superposition may seem bizarre because it goes against our everyday intuition. In the macroscopic world, we don't see objects existing in multiple places at the same time or being in multiple states at once. This is because the effects of quantum superposition are most noticeable at very small scales, like atoms or subatomic particles. At larger scales, the effects of quantum superposition tend to wash out due to interactions with the environment, a phenomenon known as decoherence. This is why we don't see superposition in our everyday lives. Quantum superposition has profound implications for our understanding of reality. It suggests that the classical idea of an objective, fixed reality doesn't hold true at the quantum level. Instead, reality at the quantum level is probabilistic, meaning that particles don't have definite properties until they are observed. This has led to many philosophical debates about the nature of reality and the role of the observer in shaping what we perceive as real. In addition to its philosophical implications, quantum superposition also has practical applications. One of the most exciting areas where superposition plays a key role is in quantum computing. In classical computing, bits are used to represent information, and each bit can be either 0 or 1. In a quantum computer, however, quantum bits, qubits, can exist in a superposition of both 0 and 1 at the same time. This allows quantum computers to perform certain calculations much more efficiently than classical computers, because they can process many possibilities simultaneously. While quantum computers are still in their early stages of development, they hold the potential to revolutionize fields like cryptography, drug discovery, and artificial intelligence. Another area where quantum superposition is important is in quantum cryptography, which uses the principles of quantum mechanics to create secure communication systems. In a quantum communication system, information is transmitted using particles in superposition, and any attempt to intercept or observe the information would disturb the superposition, alerting the intended recipients to the eavesdropping. This makes quantum cryptography an extremely secure method of communication. Quantum superposition is also central to the emerging field of quantum teleportation. Quantum teleportation involves transmitting the state of a quantum particle from one location to another, without physically moving the particle itself. This is possible due to the phenomenon of quantum entanglement, where two particles become linked in such a way that the state of one particle is dependent on the state of the other, no matter how far apart they are. Superposition plays a crucial role in this process, as the particles involved exist in a superposition of states before the teleportation occurs. Despite its strangeness, quantum superposition is one of the most fundamental and well-established principles in quantum mechanics. It has been confirmed through numerous experiments, and its effects are observable in many different quantum systems. While the idea of particles existing in multiple states simultaneously may be hard to grasp, it provides a powerful framework for understanding the behavior of the universe at its most fundamental level. In conclusion, quantum superposition is the idea that particles can exist in multiple states or positions at the same time, rather than being in a single, definite state. This concept challenges our classical understanding of reality, where objects have fixed properties. Quantum superposition has been demonstrated in experiments like the double-slit experiment and has practical applications in fields like quantum computing and cryptography. While its effects are most noticeable at the quantum level, where particles like electrons and photons behave in ways that defy our everyday intuition, quantum superposition continues to shape our understanding of the universe and our exploration of the quantum realm.